Good afternoon and welcome to the second keynote address of the 2020 Cislunar Security Conference. This presentation, including any audience Q&A, will be held at the unclassified level. At the end of the keynote, Dr. Binning will be moderating questions from our speaker from the audience, so please use the Q&A panel accessible at the bottom of your display to submit questions at any time. To introduce our distinguished speaker, it's my pleasure to welcome Dr. Ralph Semmel, the director of the Johns Hopkins Applied Physics Laboratory. Dr. Semmel, over to you.
Thank you, Vinny, and welcome again, everyone, to this first ever Cislunar Security Conference put on by APL. Like all organizations, the labs had to work through the nuances and complications of putting on a conference remotely via video. Doing so at 3 different classification levels is even more of a challenge, so I congratulate our National Security Space Team and all of our technical and logistics folks for making it happen. When you think about military space, we are in a time of transition in terms of global power, politics, and warfighting technology, a time not unlike the era producing the independent Air Force more than 70 years ago. And like its parent service, the U.S. Space Force has had to overcome various hurdles to enable its establishment and evolution. From APL's perspective, the creation of a military space service was most welcome. And not just because of the lab's long pedigree in space, one going back to Sputnik and APL's creation of satellite navigation with the transit system. The lab knows well the vital importance of space to the nation's economy and operations, and has also observed with concern the intense and increasing competition our nation is facing in space. And we also recognize that this challenging domain requires solutions at the intersection of strategy, technology, and national defense. For APL, this includes leading projects like the Space Force's Deep Space Advanced Radar concept to provide our nation with better space domain awareness. And in the Space Security and Defense program, we will be focused on enabling protection of our national space infrastructure. Similarly, our involvement in the new Space Warfighting Analysis Center will merge APL's experience in military weapon systems, air and missile defense in particular, with our expertise in space systems engineering to provide new warfighting capabilities. Clearly, there's much happening and much to do when it comes to securing space, particularly Cis Lunar Space. And so we are very fortunate to have as our keynote speaker today, the first Vice Chief of Space Operations, General David D.T. Thompson. You all have his official bio, which shows a variety of assignments in the military space arena and describes the daunting scope of his current duties. Along with assisting the chief in his organize, train, and equip functions, General Thompson is also responsible for integrating space policy, guidance, coordination, and synchronization of activities for the Department of the Air Force. It is a lot to do, but as a 2-time heavyweight boxing champ at the Air Force Academy, he's well prepared for the bouts ahead. Of course, it also helps that he has advanced degrees in aeronautics and astronautics from Purdue University, as well as a degree from Johannes Kepler University in Austria, where, by the way, he studied as an Olmsted scholar. So rank aside, and despite the Trekkers or even the Trekkies' best efforts so far, it's still general rather than admiral. He really knows this stuff. That was clearly evident in the discussions I had with him on Friday when we talked about ways to further strengthen the already robust relationships among the Space Force, APL, and the broader community, both at this conference and beyond. So please join me virtually in welcoming General David Thompson. General, over to you, sir.
Dr. Semmel, thanks so much for that kind introduction. And let me add as well, I appreciate and have seen firsthand over the years and been a beneficiary firsthand of all that John Hopkins and APL has done to advance both in terms of doctrine and thinking and technology and capability in space. And so thanks today for the introduction. Thanks for hosting this important conference. And most of all to you and the entire organization for your long history of supporting the nation, its security, and in this case, the security in space. And yes, while true, I was at one point a boxer, it has been quite a few years. And so not only because it's virtual, but also because I'm incredibly old, anybody who thinks that they might be threatened by my past in that regard shouldn't have any worries going forward. Okay, I'd like to, first of all, let me say, I had the opportunity to walk through the agenda, to understand some of the pieces of the agenda, and first let me say that I'm envious of those of you who get to spend more time and attention and actually participate in the broader agenda of this conference. There's a lot of important topics. The folks bringing some of the briefings and the ideas forward are certainly well respected, have deep understanding, and I would have benefited greatly from sitting with all of you among the audience, listening, learning, and understanding. But I do have a few minutes today. I'd like to talk to you about a few things. I'm going to apologize in some senses if it's been covered already, but the things I have to say here, first of all, I think are worth saying more than once, and second of all, I think are important for all of us given where we are today, the threats and the challenges and the opportunities that are before us. And so with that in mind, I'd kind of like to focus this around three main areas. The first is to make sure that we are all using the same definition of cislunar. Obviously, this is a Cislunar Security Conference. But what I would like to do to start with, at least for my remarks, is make sure that I've defined for all of you what I'm talking about when I'm talking about cislunar. And I'll start with an anecdote from my professor at Purdue University 30 years ago, Professor Kathleen Howe. Some of you may know her, and certainly she has a world-renowned reputation in this area. She was my advisor 30 years ago, and about a year ago, I had the opportunity the first time to go back to Purdue University to talk with them about some of the things they were doing to help advance the nation's security in space. And one of the specific topics I had asked about was, I wanted her perspectives and opinions on Cislunar and some of the work that the Cis Lunar Center there does as well. And I asked her what interests and areas and focus that I should be concerned about as one of the nation's national security space leaders. What should I care about? What should I focus on with respect to Cis Lunar Space? And her first comment to me was, she said, David, and she is still one of the few individuals on this planet who calls me David and calls me David to great effect. She said, David, I will remind you that Cis Lunar Space begins at sea level on the surface of the Earth. And of course, you know, the professor from 30 years ago is still the professor today, and the student from 30 years ago is still the student today, and she was exactly right. As we all should know and remind ourselves, Cis Lunar Space does in fact encompass all of the space surrounding the Earth-Moon system. What I believe, however, is many, when they refer to Cis Lunar Space, are actually referring not to the entire space in the Earth-Moon system, but rather either lunar space, that is the space around the moon, or perhaps the space above GEO on the way to the moon. And even if specific individuals, when they refer to Cis Lunar Space, are appropriately referring to space in the entire Earth-Moon system, those that are thinking or listening are often thinking of Cis Lunar Space as lunar space rather than Cis Lunar Space. And so of the many terms we use, whether it's near Earth or deep space, or you know, our favorite orbital regimes, whether it's LEO or GEO or MEO, I would encourage, as we continue this conversation and debate in many areas going forward, when we talk about these specific areas of space, ensure there's a common understanding of what it is. You know, and when it's cislunar, to me, it means the space of the entire Earth-Moon system. And so, with that being the case, the next question, and part of the debate that we've seen in the trades and in the press recently, has been a debate concerning the regions of space with which the U.S. Space Force should be concerned. And generally, it's a discussion of should the U.S. Space Force be focused and concerned about near Earth, what I'll call missions and capabilities and threats and challenges and opportunities from about geosynchronous orbit down to low Earth orbit? Should the U.S. Space Force be concerned and interested and focused on missions and challenges and opportunities in lunar space? Should it already be looking beyond lunar space to challenges, opportunities, and interests out further into the solar system? There seems to be a discussion and a conversation about where the focus of the U.S. Space Force should be when it comes to operating regions in the space domain. And I would say that while it might be interesting to some folks, it's not a particularly difficult or important discussion. And here's why I'll say that. Because frankly, the U.S. Space Force is and should be concerning itself with going and operating anywhere in space where its missions require it to go. The United States Space Force has been given missions in law, both by the Congress and President and others. And if you look at what the U.S. Space Force has been asked to do as a service, it is to organize, train, equip, and present space forces to do three things. The first is to deter aggression. The focus of that deterrence is primarily in, from, and through space, but it is to deter aggression. The second is to conduct space operations. That's relatively obvious and straightforward. But the third is specifically to protect the interests of the United States in space. And so what that means is the U.S. Space Force needs to be prepared to go and to operate and conduct missions and activities anywhere it is required to be to protect the interests of the United States in space. When we talk about things like that, does that mean near Earth? Does it mean lunar space? Does it mean all of cis lunar space? Does it mean interests heading out into the solar system? Well, I would ask you, I would look at a couple of examples and draw conclusions from them. And the first is to look at my ancestral organization now, the United States Air Force. That would be like asking whether the United States Air Force is a tactical Air Force or a strategic Air Force. Is the United States Air Force a combat Air Force or a mobility Air Force? Similarly with the United States Navy, is it a blue water Navy or a brown water Navy? Is the United States Navy a surface Navy or a subsurface Navy or an above the surface Navy? And the answer both to the Air Force and the Navy and the Army and the Marine Corps and the entire armed forces for that matter is these services and forces they organize, train, and equip and present forces. They train their forces. They develop and field and operate capabilities that do what the United States needs them to do, that ensures they can protect the interests of the United States in the air, on land, at sea, in cyberspace, and in our case, in space. And so it isn't really a discussion about whether the U.S. Space Force should be focused near Earth, or whether it should be a cis lunar force, or should it be a lunar force, or should it be a force that looks onto Mars. As a matter of fact, and frankly stated, the U.S. Space Force needs to go where it needs to go to create the capabilities and prepare and present forces it needs to present in order to protect the interests of the United States in space. And just like those other services, the Air Force and the Army and the Navy will organize, train, equip, and present forces to do exactly what it needs to do in that regard. And so is the United States Space Force focused on near Earth? Absolutely. Is the United States Space Force interested in, focused on, and understanding what it needs to do in cislunar, all of cislunar space and lunar space? Absolutely. Does the United States Space Force need to have its eye on and consider and think about what it will be doing in the future as humankind ventures more aggressively beyond cislunar space and out into Mars and further into the solar system? The answer to all of those is absolutely. What it becomes a matter of, which has always been a matter of, is when we live in a society and we live in a situation without unlimited resources, it becomes a matter of priorities and weight of effort. And that's the real question today, is not whether we should be interested in or focused on or concerned about any of these regimes. We need to be concerned about all of them. The question is, where is our priority and weight of effort and why? And that's really the challenge that the Space Force faces today. And as we think about it, and we think about our responsibilities to deter, to conduct space operations, to be part of a larger joint force, to protect the interests of the United States in space, and frankly, to be part of the joint team that is prepared to fight and win the nation's wars. The primary weight of effort and focus for the U.S. Space Force today is what many call near Earth, which is frankly geosynchronous orbit, about at geosynchronous orbit and below. And the reason is there are multiple reasons why that's the case. The first is that is where the bulk of our security challenges are faced today. I'm sure I don't need to talk to most of you about the activities of Russia, the activities of China, and the activities of other adversaries who understand the value and the importance of space to military operations today, see the advantages we've gained, and are doing two things. The first thing they're doing is looking to take those advantages and capabilities away from us in conflict. And the second is replicating those capabilities so they themselves can use them as part of military operations. And so that threat that it poses, that our adversaries pose in terms of our ability to use space and in ways that matter to soldiers and sailors and airmen and Marines, all the way up to our national leaders, are threatened by adversaries in near Earth today, and therefore we have to be concerned about providing those capabilities, protecting them, defending them, ensuring they're available and part of the joint force across all phases of conflict. The second thing is when you look at the exploitation of space today for civil purposes, for public safety purposes, and for commercial purposes, the vast majority of that benefit comes from operating in near Earth. Satellite Industry Association, among others, have talked about the economic benefit we get from space these days, now north of $300 billion annually in terms of global economic benefit from space. That continues to rise rapidly. Certainly, expectation and forecasts say in the next decade or so that is expected to exceed $1 trillion. But the vast majority of that benefit comes from commercial services and other activities focused in near Earth. And so with that, and because of that today, because of the criticality to national security, because of the civil benefits that it serves, because of the commercial and economic benefits provided by operating near Earth, that has been and will be for the near term the priority and weight of effort for the U.S. Space Force in terms of deterring adverse behavior, in terms of developing fielding capabilities, in terms of the operations that we conduct and the activities we pursue, because that's where we can best protect and defend the interests of the United States in the near term. Now, as I said, just as the United States Air Force is not a tactical or strategic air force or a combat or a mobility air force, the U.S. Navy is not a blue water or a brown water Navy. It is all of that and what it needs to be. It absolutely means that the U.S. Space Force is focused on and interested in doing things related to activities beyond near Earth, out into all of Cis Lunar Space, out into lunar space. There's significant evidence of that. You've seen and heard some of that as part of this conference today, and you've seen it in other areas. But in that regard, I would like to talk a little bit about our thinking with regard to lunar space, space above geo, and beyond, as we, the United States Space Force, and all of you head into the future. And as we think about the use of space above geo and into lunar space, the U.S. Space Force is thinking about it in a couple of ways. The first is how to effectively use and exploit that region of space for what I will call Earth-centered missions today. Just as we conduct a whole variety of missions that are Earth-centered or that are Earth and terrestrially focused today, whether it's positioning, navigation, and timing through GPS, whether it's connecting the forces and our national leaders through satellite communications, excuse me, whether it's the partnership that we have with and the personnel and expertise we provide in the work we do with the National Reconnaissance Office on ISR, or our own indications and warning systems that we use. Much of what we do clearly and the important work we do is focused on forces on the ground, civil and commercial activity on the ground, national security, security of our partners. And so we ask ourselves, excuse me, how can we use that space beyond geo and all of Cis Lunar Space to the benefit of those missions today. And there are certainly things we're considering, and there's work being done. But there are, as you all know, significant challenges with operating in those regimes when we think about the benefit and the effect from space. Excuse me just a minute. First and most obvious is the challenge of distance. If the intent and the desire is to support activities on the surface of the Earth, when you talk about sensors and sensor ranges, when you talk about delays, and when it comes to communications and transmission of data, when it comes to the idea of travel time when traveling in Cis Lunar Space, especially above GEO, all of those factors, while not not absolute bars to operating in those regimes for the benefit of activity on the Earth, they do present unique challenges and considerations when it comes to the effectiveness, the cost, the effectiveness, and the utility of missions that might be conducted in that regime. Certainly worth considered study and examination and thought. But today, when you think about the fact that the provision is for data relay, that the provision is for sensors and information, and providing information advantage to joint forces, to our national leadership, and even in commercial and civil activities. Today, operating systems significantly out beyond GEO brings with it challenges that at this point don't point to extensive use in that regime for additional missions. Not an absolute exclusion, as I said, but it does create challenges. The same with the orbitology associated with operating above GEO. Obviously, GEO is GEO for a reason because of its because of the synchronicity of the orbital period with the rotation of the Earth. And so there's, as you all know, there's good reason why we operate in GEO today, and other reasons why we operate below GEO today. And so when you think about, first of all, the technology where it is today, sensor capabilities, distances involved, orbitology involved, generally speaking, most of our interest and activity and the effectiveness of our missions are when we're thinking about the effect on the Earth, effect on the ground, at sea, in the air, and other places on the surface of the Earth, really drive us continued toward what I'll call that near Earth regime. However, opportunities do exist. We'll continue to explore them, and as we move into the future, as technology allows, as thinking develops, as missions evolve, it may well be that we find increasingly ways we can, will, and desire to operate in that area above GEO for the purposes of supporting missions and activities on the Earth. The second piece of it, however, is, as we discussed before, we absolutely are thinking and moving and developing ideas in the direction of how should the U.S. Space Force be thinking about the lunar spaces, and specifically space around the moon and beyond, in terms of protecting the national security interests of the United States. There's no question that there are security interests of the United States today in Cis Lunar Space, really in space above GEO. It's certainly centered on the moon in many cases, and there's absolutely no question that with time, as NASA and commercial companies and others increasingly and aggressively move back toward the moon, the interests of the United States will continue to grow there, and the roles and responsibilities and expectation of the U.S. Space Force to protect those interests will grow. And we recognize that. We understand that our boss, General J. Raymond, has said that very clearly. And so we are preparing for those days when the interests of the United States will begin to emphasize more and more lunar space and Cis Lunar Space above GEO. And so you ask yourself now, okay, what does that mean in terms of the things we ought to be and are doing today? And there's certainly a number of things that we are doing already and need to grow and develop and continue today in that regard. And the first is, and probably the most important, at this phase of development of any capability, any vision for the future, any potential area, regime, mission we might be pursuing in the future. The first is to think carefully and deeply about what it should look like, what the interest will be, what our responsibilities should be, the kinds of capabilities that we should be pursuing to support that mission, the types of technologies and challenges and issues that might be effective in that regard. All of those things begin with thought. And that's what I enjoy most and appreciate most about some of the debate going on about Cis Lunar Space, Cis Lunar Security, and security and activities in the lunar space, is the thought that is underway today about what the future should look like, what roles and responsibilities should be, what missions the U.S. Space Force might have, how it might partner with NASA, with other nations, with commercial companies. All of that thought inside and outside of the U.S. Space Force is vitally important to moving forward in terms of what the future in beyond GEO, first of all, into lunar space and beyond should look like. The second is absolutely there should be planning that goes along with it as well. Obviously, we need to be sufficiently developed in our thinking, in our understanding, in our expectation of what we will be doing, what we must do, what the timelines involved are, and ensure that that thought has been recorded in the plans that ultimately that become doctrine and strategy and eventually become a resourced set of activities that ensure when the time comes the U.S. Space Force is ready to protect the interests of the United States in those regions as will be expected. The next is to experiment. And in fact, that's a lot of what you're seeing today. I'm sorry, in this session, the work that the Air Force Research Lab is and has been doing, the work of some of the other DoD agencies and supporting laboratories that you're discussing in this conference, experimentation associated with what it means to operate in that regime, the effectiveness of operating in that regime, the value of operating in that regime, and the types of systems and sensors and technologies that will benefit us in that regime. And so there's experimentation going on today, and I would say with time, that experimentation, that technology development will need to grow as we understand through thought and planning more deeply the capabilities we need, the operating concepts we'll use, the interests that will be required to protect. That experimentation will help us ensure that we have the technologies, we have the operating concepts and understanding, and we have, no kidding, ultimately the systems and capabilities that we need. And so that is ongoing as well. And then finally, no kidding, not just thinking and planning and experimenting, but really taking steps in the direction to ensure that we're ready to do what the nation needs us to do as we continue to move into those regimes above GEO. We're doing it already in many cases, and obviously the first is an understanding of what is going on in the domain, space domain awareness, not just space domain awareness for geosynchronous orbit and below, but the activities that are already occurring and will be occurring in the next several years in all of cislunar space, particularly when it comes to activities around the moon. That domain awareness is the key to understanding challenges, issues, potential threats, and how to operate effectively in a domain. And as you've seen in many of these, the AFR activity regarding the Cislunar Highway among them, we are already taking steps inside of the Air Force, inside the Air Force Research Lab, inside the Space Force, but also in other areas, in other organizations with respect to domain awareness. We're also working with NASA closely on how they can use our capabilities to their benefit as they return to them. And we're doing that in a couple of ways. In fact, a lot of it is reflected in the memorandum of understanding that has just been signed between General Raymond and Administrator Brideside of NASA. At this point in time, NASA intends to navigate in lunar space with the use of GPS. Never envisioned in our early concepts and development of that system and what its intent, but over the years, NASA has become a tremendous user of GPS for space, deep space, and now Cis Lunar navigation in all of Cis Lunar Space. And so that partnership is strong in a specific area where we could support them. The second is in some of our transportation technologies, some of the data relay systems and technologies and systems that we both use today, as well as the identification of future technologies that both NASA and the U.S. Space Force will need to operate effectively in the domain. And so all of those are going on right now. It's not just a partnership with NASA. We certainly look to build partnerships with the rest of the national security enterprise, with our partners in other nations, and certainly commercially to be able to move effectively out into all of Cis Lunar Space as the nation and as the human race moves out in that regard and looks to exploit it for civil purposes, commercial purposes, economic purposes, and for us to ensure that we're there to protect all of the interests of the United States, especially when it comes to our security and safety in space. And so, as stated, absolutely all of Cis Lunar Space, lunar space near, or I'm sorry, Cis Lunar Space near the Earth, Cis Lunar Space above geo, all the way out to the moon, is important to the United States Space Force today, is the focus of activity for the United States Air Force today, I'm sorry, the United States Space Force today, and will only grow in the future. It only becomes a matter of adjusting priorities, weight of emphasis, and resourcing appropriately as we work through the nation's interests, the threats, and the missions that are required of us to complete. Thanks all. I appreciate the time today, and I look forward to your questions.
Gen Thompson, thank you for those remarks. It's good to see you again. Ladies and gentlemen, I'm Patrick Bidding from APL. We met yesterday several times in this conference. I'm going to spend 10 or 15 minutes. We have several questions that have come into the Q&A chat channel. And if you have additional questions for those in the audience, please type them in. I'll pull a few in here. And like I mentioned, we'll spend 10 or 15 minutes on some of these. I'd like to ask the first question, Gen Thompson. I'll pull a thread through some of the remarks that you mentioned. Obviously, the primary focus of the Space Force is GEO down to LEO. That's where the principal focus should be, and you won't find debate amongst the audience here in that. There are many things that are going on experimentation-wise, and you mentioned those in your remarks. And I'd like to pull the thread a little bit about, there's many organizations pursuing these technical innovations for national security applications in Cislunar. We're hearing from many of these projects this week. You mentioned AFRL. We heard from them today and later today and tomorrow. Space Development Agency has an ongoing activity. DARPA has an ongoing activity. The question I have for you is, how do you see these efforts focused on Cislunar being coordinated within the Space Force?
Thanks, Patrick. First, great to see you again, and I appreciate the question. I'll be honest, that is one of the challenges and one of the reasons I believe that the nation's leaders called for the creation of a Space Force is there are many, as you noted, many organizations, agencies, laboratories, interests, priorities when it comes to technology development, system development, capability development, architectures. People love to talk about architectures and what they should look like. The challenge has become there are so many disparate interests and voices and priorities that it was one of the reasons that the Space Force was created, I think, was to bring some harmony to that. And so the first thing that I think you're going to see out of the Space Force and General Raymond and his intent particularly is to outline a force design that's associated with a strategy and talk about what the nation, as the nation's leader and one of the primary voices for national security with respect to space. He's going to outline the priorities for the nation in terms of national security, the expectations he believes comes to the Space Force, and as a result, the force we need to design, build, and field to do that. That also comes with underlying operating concepts, comes with underlying foundational technologies, and a supporting level of experimentation technology development that comes with it. And so what I will expect and anticipate is in the future, as these groups pursue these activities, the question will be, is that consistent with, and how does it match the force design that the U.S. Space Force has outlined? And I think that's one of the big early ways that the Space Force will bring some harmony to that set of activities.
Great, thank you. So I want to follow up also on your initial opening remark. Professor Howe is obviously an icon in the astrodynamic community, and operating beyond LEO and beyond GEO is a different environment from an astrodynamic perspective. And so in terms of education and training, with the differences in operating beyond GEO, making predictions more difficult, making where folks are going and things of that nature, it doesn't make for an easy two-line element set from the 60s to fit it all. What might the Space Force need in terms of education and training for the cislunar area, a non-traditional Space Force realm, and how should this audience be thinking about helping the Space Force?
Great question, Patrick. Let me say, and let me start with, it's an issue and a challenge not because of the additional complexities of the physics and the astrodynamics and the operating regime above GEO. Absolutely, we believe, and have probably for far too long not been serious about recognizing, let's just say, the deep underlying technical knowledge that is required for operators to understand space and operate effectively. The example I like to use is, while individuals may not fully understand the way an airplane works, or the way a car works, or the way a sailing ship or any other ship works, they kind of innately understand what it means to fly an airplane, what it means to sail a ship, what it means to drive a car, even if they don't understand all of the underpinnings from a technical standpoint. That's not true in space. In fact, many of the operating principles in space are counterintuitive. And so across the board, whether you're operating in LEO, GEO, or beyond GEO in the broader area of cislunar space, a deeper understanding of the domain, the physics of operating in the domain, and how to operate in the domain effectively is required of all members of the Space Force. And so what we are doing, in fact, as part of a human capital strategy, is a couple of things. Is we are building up, first of all, the technical education and expectations of the entire force. That's not to say that every member of the Space Force needs to be a scientist or engineer, but we're going to expect they have additional scientific, technical, mathematical education coming into the force, or we will provide it as part of their initial training. Second thing that we are doing is increasing our expectation and demand for advanced degrees beyond an undergraduate degree, master's degrees, PhDs, not in a boutique set of members of the force, but for the broad set of the force. And so as part of that, it won't just be a matter of their education, but it will also be a connection to research activities that are related to building and developing the Space Force. And so what you can expect in that regard, particularly, is a larger demand signal for for our partners, our laboratory and academic partners, to educate, train at the undergraduate level, at the graduate level, and in terms of research and development activities. A closer interaction with our members of the force as we build into them the demand for greater expertise when it comes to the scientific, technical, and engineering aspects of operating in a domain.
Good, thank you for that. So WIS Conference is thinking far ahead. I'm going to pull a question from the audience here, which is one that's reaching out there regarding to things in the future. How important do you see space logistics and space servicing in the Space Force's cislunar operations strategy? Is this an area the Space Force is working on in this area today?
So in terms of the Space Force, I would call it nascent. And nascent for a couple of reasons, in a couple of regards. One of them is because the technologies and the ideas and the concepts themselves are a little bit nascent. But the other thing I would say is I think we see this as an area that's ripe for commercial and entrepreneurial development and activity. There is absolutely no question in terms of, let's call it space transportation, space logistics and supply, the routine movement of objects across regimes and orbits in space. We think there's an opportunity there, hopefully in the commercial market, and there's some entrepreneurial drive there to bring those services and those capabilities to bear. What I would say is, if available to the Space Force, we absolutely see a purpose for them and a use for them in how we build, how we deploy, how we operate, how we move, and how we manage our systems and our capabilities in space. But I think today our answer is, and again, it's a little bit of a balance of priority and weight of effort against resources. Hope that's an area of commercial activity. See that as a potential service provided, not just to the Space Force, but others in the future. But certainly, if the service is available, certainly see a vision for how the Space Force would use it and use it to great effect.
Thank you. And this will be our last question from the audience as well regarding the responsible use of Cislunar. What role do you see the Space Force having to ensure the responsible use of the Cislunar domain in maybe the definition from sea level beyond, but potentially the geosynchronous beyond domain? What role do you see the Space Force having ensuring the responsible use of that area?
I think first and foremost, we're going to need to be an exemplar, an example of responsible behavior. I think the entire space community is going to have to think about that differently in the future. Obviously, as you think about things like, we've got the super synchronous graveyard orbits that have served effectively for a long time. I think we're going to have to rethink, perhaps through the idea of space transportation and logistics, whether we need to rethink about that behavior, certainly in terms of the way nations and military forces operate in space today. We need to establish norms of behavior, standards of conduct, the things that armies and navies and air forces over the millennia and centuries and decades have learned how armed forces need to coexist and operate together in the same area effectively. We need to be a driver for moving forward with those standards of behavior, how to operate effectively, how to operate safely, what is acceptable behavior, what is not acceptable behavior. I think we will play a large role and need to play a large role in helping to define expectations and demonstrating what it is in that regard. And I would say that you've probably seen some of that in recent months with General Raymond and his discussion of some of the behavior of the Russians and others, and our belief that it was hostile and unsafe and unprofessional. So both in that sense of helping to define those, being an example, but also driving things like being good stewards of the domain generally day to day beyond Cis Lunar Space.
Well, that wraps up the Q&A portion of our keynote. General Thompson, thank you. Would you like to share any closing remarks before we close out this address?
Yeah, I would say again, I appreciate not just APL, but what all of you have done and are doing to stimulate the thinking, to stimulate the debate, to drive investment, to drive technology development, whether it's on the military side, on the commercial side, in terms of doctrine, in terms of theory, in terms of operating concepts. I think this is perhaps as exciting a time to be involved in space since the days of the 60s and the Apollo program. And I appreciate the energy and passion and drive and energy that you all are bringing to it as we proceed, developing the Space Force, but also defining what it's going to mean for all of us to operate in space for the coming decades.
On behalf of the audience, on behalf of the program committee, and on behalf of the Applied Physics Lab, General Thompson, thank you so much for spending part of your day with us, and thank you for your remarks.